Okay guys, so today we're going to look at factoring. Okay, we've already seen some special patterns, difference of squares and perfect square trinomials and even cubic patterns, but not everyone follows that, right? Sometimes they're just going to be regular factoring problems without a special pattern. So we're going to try to develop some strategies to help us figure that out. And there's really two main situations, okay? One, let's start at the top. When the coefficient in front of the x squared is 1, these you might have seen before. In fact, I know you've seen before, and you probably feel pretty comfortable with them, but let's quickly review them, okay? So again, these are situations when the coefficient in front of x squared is 1, okay? All we're going to do is we're going to find numbers. I'm looking at this blanks here. Find numbers that multiply to the last term, okay, and add up to the middle term. Okay, you may have done this before, you may have not. I'll just take a look how this works in practice. So we have this function x squared plus 6x plus 8. We want to factor it. Probably can do this in your head, but let's kind of walk through the process. What are some factors of 8? Well, I know 1 and 8 are factors. Okay, 1 times 8 does equal 8, but does 1 plus 8 equal 6? It does not, which tells me that's not one of the solutions. Another possible solution could be 2 and 4. Those are also factors of 8. Do 2 times 4 equal 8? Yes. Do 2 plus 4 equal 6? It does. Hence, this is our winner, right? So when we think about what it factors to, it's going to factor 2x plus 2 times x plus 4. Okay, that's simple. Let's take a look at, let's try number 2. So we have x squared minus 3x minus 40. Okay, so what are some factors of 40? And again, don't worry about the pluses or minuses here when you think about the factors. Just try combinations of both. So I'm going to try 1 and negative 40. I know one of them has to be negative because I know it needs to multiply to negative 40. But 1 plus negative 40 certainly does not equal negative 3. And I know negative 40 and positive 1's not going to work either. I just kind of know that from logically looking at it. What about 4 and 10? So let's try negative 4, positive 10. Does multiply to negative 40, but it adds to positive 6. Okay, so that doesn't work. What about positive 4 and negative 10? Adds to negative 6, so that doesn't work. Let's try this, 5 and 8. So what if I try 5 and negative 8? Well, 5 times negative 8 is negative 40, and it does add to negative 3. So those are my two answers, the winners. So it would factor 2x plus 5x minus 8. Okay? As you look through these, they're all kind of the same. They follow the same process. So why don't you guys try just 4 through 6. Again, this should be review for you, but try working through 4 through 6 here. Well, oops. That one, and that one. Now if you're done, let's move on. Okay, the only other situation we have to worry about, when I say only is a little bit of an understatement, but when the coefficient in front of x squared is not 1. Okay, so let's take a look at the example of 5a squared plus 23a, okay, plus 23a plus 26. Okay, there's a lot of different methods to solving this. The method I'm going to show you is not the only method. If you have another method you've learned before and you want to use it, you can do so. But this is the method I'm going to teach in here. Okay, so step 1 in this method says place in 2 separate columns factors of the first term and last term, and in the column with the least number of factors, include the reverse order as well. Okay, and that kind of makes sense as we work through this. So let's take a look at the first term, the 5a squared. So I'm going to write first over here. What are factors of 5? Well, it could be 1 and 5. Okay, and since I know that 5 has less factors than 26, this is the column I'm going to use the reverse order in. So there's 1 and 5, but it also could be 5 and 1. Okay, in the last column, the 26, I'm also going to list out the factors, but I'm not going to worry about reversing the order. So what are factors of 26? Well, 1 and 26, and 13 and 2. So now that I have those listed out, okay, step 2 says figure out which pair from each column can give you the middle term in the trinomial when you add the product of the first terms with the product of the second terms, okay? And I should say, when you add, you could also subtract, okay? So let me actually write that in, and you'll see that example later on in another problem. When you add or subtract. In this case, we're going to add, as you see. So let's take a look at this. So let's take a look at 1 and 5 and 1 and 26. Does 1 times 1 plus 5 times 26, does that equal the middle term of 23? No, clearly that does not. 5 times 26 is what, 130? So you get 132. That does not equal it. Let's take a look at 1 and 5 and 13 and 2. Does 1 times 13 plus 5 times 2, does that equal 23? It does. Again, I'm looking at these two terms right now. Does 1 times 13 plus 5 times 2 equal 23? It does. That is going to be my winner. Okay? So these two, right, are the winner to step 2. Okay? Taking a look at the product, okay, of the first term in each column, plus or add or subtract the product of the second terms, and seeing if they get you that number, okay, that middle number, the trinomial. So we've got what we're looking for. We've got 1 and 5 and 13 and 2. So step 3 says once you have the two pairs, rewrite both separately, placing 1 underneath, and change any signs necessary to ensure the sum of the product of the two vertical columns add up to the middle term coefficient. All right, so a little bit confusing, but let's just kind of follow this, okay? The two winners were 1 and 5, 1, 5, and 13 and 2. So we place one underneath another. We're always going to place, okay, the first terms on the top column and the last terms in the bottom column. So 1 and 5, 13 and 2. And all we're looking for, guys, is to see that the sum of the product of each column, okay, gives us the middle term of 23. So does 1 times 13 plus 5 times 2 equal 23? It does. We don't have to change the signs on any of them, i.e. make it 13 negative or 2 negative. They're both positive. So those are our winners. Okay, so we don't have to change anything, but it's a good check to do this, and I'll show you how we do this in the future when there are some negatives. Okay, and then step 4 says the diagonals of the square box will be each binomial. So what I mean by the diagonals is, now that we know that those are our winners, that here's one diagonal, 1 and 2, here's my second diagonal, 5 and 13, okay, are going to be our winners. So let's actually write this out. The 1, okay, in the first diagonal represents the coefficient, okay, which in this case would just be, I think we got a as our variable, so it'd be a, 1a plus 2 times, now the 5 above here, right, the 5 here represents the coefficient of my next binomial, so it'd be 5a plus positive 13. Okay, we've now factored that. It's a little bit of a process, I know, but it gets, it's repeatable, okay? It becomes easier the more you do it, okay? It is repeatable. And the last step, give the person or animal you're at home sitting next to a high five. I'm sitting here in a classroom. I have no one to high five, so sad for me. Let's do number 7 together before we go. Let's try number 7, because this one actually involves a negative. So we have 2p squared minus 27p plus 36. So again, all we're going to do first is just list out the factors in each column, remembering the number with the least number of factors. We're going to have to write the reverse order as well. So let's take a look at the 2, okay? So first column, put it black here. First, what are the factors of 2? Well, it could be 1, 2, or it could be 2 and 1. Okay, 36 is a little bit harder. There'll be a few more factors, but the fact that we don't have to write out the reverse order makes it a little easier. So what are factors of 36? Well, we've got 1 and 36. 9 and 4, 6, 6, 12, and 3. So again, now what we're looking for is we're looking at the product, okay? Looking at the product of the first term in each column plus or minus the product of the term in the second column. So let's again take a look at this. Let's take a look at 1 and 2 and 1 and 36. Does 1 times 1 plus 2 times 36 give me negative 27? Okay, or positive 27? It does not. 1 times 1 minus 2 times 36. I'll write this out. 1 times 1 minus 2 times 36. Does that equal negative 27? It does not. So clearly that's not our winner. Okay. Let's try the next one. Does 1 times 9, okay, minus 2 times 4, does that equal negative 27? Okay, we get 9 minus 8. Okay, doesn't work. What about adding them? 9 plus 8 is 17. 17 is not 27. That doesn't work. Okay. So as I look through these, I know none of these are going to work. You can work through those examples. But what I do know to speed this up, having done this before, that if we look at 2 and 1 and 12 and 3, those are going to be our winners. Let's take a look at this. Does 2 times 12 plus 1 times 3 equal 27? Excuse me, negative 27. Well, you might say, well, Mr. Butter, that's 27 equals negative 27. That doesn't work. Well, we can change the plus or minuses on these later to get the negative 27. What I do know is I can get the 27 out of that. Okay, so don't worry so much that that middle term is negative 27 as that we can find the product or the sum of the product of those two numbers to get 27. I can worry about making that 27 here, negative 27 in a minute. And you'll see how that works. So let's, like we said, line up the two winners in the box there. So let's do, change the color. Let's do 2 and 1 and 12 and 3. And again, we want to look at, does the sum of their products in each column equal negative 27? Here's what we need to worry about, okay, the sign difference, okay? So let's take a look at 2 times 12. 2 times 12 is 24. 1 times 3 is 3. 24 plus 3, we need to equal negative 27. Does 24 plus 3 equal negative 27? It does not. So what could I do to the numbers above, the 2 and the 12 and the 1 and 3, to get negative 27? Well, I could just make the 12 negative and the 3 negative. That would make negative 24. That would make negative 3, which would sum to negative 27. So this is what I mean when we change the sign. We're going to change them on this step right here. Okay, this is the step we're changing them on. Always change the number, the sign, and the numbers in this row. Don't change the numbers up here, I'll say. Let me just write that. Little arrow. Don't change, because these are your leading terms. You always want your leading terms to be positive, so don't change signs on leading terms. So we know my winners are 2 and negative 12 and 1 and negative 3. So if we were to write out our final answer, okay, we're going to get 2p, don't forget the variables, p, 2p minus 3. Don't forget, we're looking at the diagonals, not the verticals, right? So here's our winner, 2p minus 3, and p minus 12. Okay? So it's a little bit of a process. It takes some practice. If you're still a little bit hazy or feeling like, I don't quite have it yet, that is okay. Give yourself a break. You've only done 2 problems like this in your life with this method, okay? So give yourself a little bit of a break. In terms of the problems to do for homework, I'm just trying to think of some ones here. Let's try number 8, okay? I'll do it in green here. So let's do number 8. Let's do number 7. And just to make life interesting, let's do number 10. Okay, oops. Let's do number 10. So for homework, okay, if you haven't already done the ones above here, I want you to do going 4, 5, 6, and I want you to try, scroll down here, 8, 9, 10. Come to class with questions tomorrow, and we'll talk about it then.